Okay, so this time, question 4, we've got a differentiation question. A differentiation question in context, because we've got to apply it to various things. It's not just dy by dx, it's dv by dx, but we aren't going to let that fool us. The diagram shows a solid cuboid with sides of lengths x, 3x, and y. Think like a cornflake box or a tissue box. There are no squares here. The total surface area of the cuboid is 32, so there's fact number 1 that we're told. We've got to show that 3x squared plus 4xy equals 16. Where on earth does this come from? Surely it must come from this fact here, probably. So how do we work out the total surface area? Well, we've got the front and the back. That's going to be equal to 3x times y times that by 2, because we've got front and back, giving us 6xy. We've got the left and the right hand sides. They're going to be equal to x times y, and we've got 2 of those. So we've got 2 more xy's. If we now just, what have we got next? The top and the bottom. Okay, so that is 3x times x, which is 3x squared. 2 of those giving us 6x squared. Okay, putting this all together, what have we? 6x squared. Sorry about that. Okay, putting this all together, what have we got? We've got 8xy plus 6x squared. And don't forget, we're told that's equal to 32. That's the other side of the equation. Looks a bit similar. X squareds go first, then the xy's, and I can see everything's been halved. It's halving everything and putting the other one, the x squareds first, gives us 3x squared plus 4xy equals 16. Job done there. Part 2, hence, use what we've just done, show that the volume V of the cuboid is given by this. Just thinking back to basics, how do we work out volume? We work out volume. Volume is equal to length times width times height, which would be all very well. We just do 3x times the width, which is x, so 3x squared times the height, which is y. All very well, but I can see there are no y's in here. Hence, so using what we already know. So can we rewrite this whole thing in terms of y? Yes, we can. Just by moving the 3x squared over, we've got 4xy is equal to 16 minus 3x squared. Dividing the whole lot by, or dividing both terms, in fact, by 4x gives us y equals 16 over 4x. Take away 3x squared over 4x. Now this will simplify down nicely, because 16 divided by 4 is just 4 on the top, minus the x's on the bottom is going to cancel with the squared, which gives me 3x over 4. So that's what y is. Okay, getting there. Now let's just sub that into our equation for the volume. We get 3x squared times by 4 over x minus 3x over 4. Multiplying it out, that times that is going to give me 12x squared over x. Well, that's just going to cancel and give me x on the top. This, multiplying this out, we're going to get 3 times 3, which is 9, x squared times x, which is x cubed, over 4. Okay, so there is our volume. We've made that. We think we're looking good. Okay, part B, find dv by dx. To find dv by dx, we're going to differentiate this. Okay, so dv by dx is going to be equal to, so differentiating that, the x's is going to go, and we're left with 12. Take away, I'm going to write this slightly differently so it's more obvious. That's 9 over 4. Okay, multiplying that, so 9 multiplied by the power, so 9 times 3, and then reduce the power. So actually what we're going to get here, we're going to get 12 take away 27 over 4 x squared. Okay, at this point I'm going to check the mark scheme so we can see how we're doing. Back to part one. There's our left and right, there's our top and the bottom, and there's our front and back. Two terms, putting it all together, and then dividing by 2. So 1 mark for the correct expression for the surface area, not simplified. Second mark for getting to what they asked us to get to. Answer given, be convinced. So we've got to really put that line in, this intermediate line, to convince them that we are working it out. Okay, 3 marks for the volume, 1 mark for putting volume is equal to 3x squared times y, or equivalent, correct volume in terms of x and y. Second mark for either of these. I think we did get to that. I remember having that with brackets. Third mark for expanding the brackets out and cancelling down. Part B, the differentiation, going right from here. 12x goes to 12. 3 times 9 is 27, still over 4. X cubed goes to x squared. One of these terms correct for 1 mark, all correct, with 9 times 3 actually worked out for the second mark. Part C, verify that a stationary value of V, stationary values occur when the differential is equal to 0. When x equals 4 over 3. Okay, so substituting x equals 4/3, so x equals 4/3, substituting it into our expression dv by dx. So x equals 4/3 implies that dv by dx is equal to 12 take away 27 over 4 multiplied by 4/3 times itself. Okay, now actually there's a long way and a short way to do this. The long way is that you multiply everything out. The short way is that you cancel the factors that you can. I can see that that will cancel with that. This is actually going to go quite nice. So at this point what we're going to have is that's equal to 12 take away 9 times 4, which is 36 over 3. Wonder what that is. 12 take away 36 over 3 is 12 equals 0. Be nice to conclude here. So stationary value at 4 over 3 at x equals 4 over 3. Okay, good. Next part, find d2v by dx squared and hence determine, so having done that, whether v has a maximum value or a minimum value at that very same point that we just found. Okay, so we need to differentiate again. So going from what we've got, d2v by dx squared is going to be equal to, the 12 is going to vanish. We're going to have negative 27 times 2 is 54 over 4. X, reduce the power, is x squared, so it just becomes x. Just as a courtesy, we can cancel that down. So it's minus 27 over 2x. Okay, and we're trying to use x equals 4/3. So if x is equal to 4/3, we've got negative 27 over 2 multiplied by 4/3. Okay, without even working it out, we can see that this is going to be negative, and so that implies that when x equals 4/3, the stationary value is, so when x equals 4/3, this is negative, so when x equals 4/3, stationary value is a maximum. Super. Your question to prove that you've watched this video is, can you please write down the cosine rule? Write down and bring in the cosine rule. Thank you very much.